presentation about Spring Boot and Kotlin. Is it a pain or a gain? We're gonna find out today. My name is Peter. I have gray hair, 20 years in the industry, so I dare to call myself a senior software engineer. I try to be as much as possible with my hands in the dirt. Also, frequently speak on conferences. Last week also the nice Kotlin Conf in Denmark, where I had the opportunity to talk. I'm also a trainer at the XCB Academy, where I actually help teams, individuals on the embarkment of their Kotlin journey, being beginner, intermediate, or advanced. When you look at my career, I of course started out with Java. Then about 10 years ago, I switched over to Scala, and the previous years I'm mostly writing backend logic in Kotlin. I won't do this presentation entirely by myself. Jadev will join, and he will be the guy that asks the critical questions. So in case I get too enthusiastic, well, I will be shut down a little by Jadev. Enough about me. I would also know a little bit more about you. So who of you has ever written a line of Kotlin? That's most of you. Excellent, cool. Who of you has production software running in Kotlin? That's almost about the same amount. Okay. And who wants to know more about Kotlin or do more Kotlin? About the same. Okay, cool. Excellent. Well, before we look at Spring Boot and Kotlin, I think for the ones that have not yet done a lot of Kotlin, it's good to emphasize why you should choose for Kotlin in the first place. If there is no value in Kotlin, why should you use it with Spring Boot, right? You might have seen presentations like that before, Java Kotlin person. Today, I'd like to take a different angle and more look at the concepts that the languages offer us and what kind of benefits of pitfall they offer. Well, you might have heard that Kotlin is a concise language. So first of all, what does this mean, conciseness? And most important of all, what kind of value does it deliver us? That's kind of a common example when you do a Java Kotlin comparison. You have this Java class with many lines, and the counterpart in Kotlin is just a few lines. But how does Kotlin manage to decode the exact same information on the left in just a few lines on the right? Well, this has to do that, first of all, the constructor declaration, field, getter, and set declaration is actually condensed into one spot. And we'll see later on, this is not only a way to limit lines of code, that's even a safety feature that's behind that. So this can be obsolete. Second, Kotlin has this very simple feature of default arguments. So when you write Kotlin code, actually almost never use overloaded methods, because with default arguments, you get your job done. Also here, a lot of code simply becomes redundant. And of course, default arguments are not only available in constructors, they're also available in every method. Another method that can go away. When you have, wait a minute, I think there is still something wrong. No, there's nothing wrong. Perfect, fine. So whenever you try to create objects in Java, it's very common to use the builder pattern, right? So either you create your own, which is quite tedious, or you let Lombok generate the builder. Kotlin has, again, a very simple language feature, which is named arguments. And because of named arguments, you actually can make the builder pattern obsolete. So no builders there, which is true for all of Lombok. Basically, all the features Lombok offer are already part of the Kotlin language itself. Collections, good collection support, I think, is as important for us as good air around us, because collections we use on a daily basis. And to have a collection that helps me rather than it's getting in my way is of course more than a convenience. It's a necessity. Let's see how the two compare there with a few examples. So if I try to take the sum of a list of integers, this is what I have to do in Java. And that's not trivial, right? You cannot just type sum and then get it. You kind of have to figure out, okay, first to go to stream, you have to read this mapping, and that's why there's a ball doing for that. And I think whenever there's a ball doing for a very simple language construct, I think you're dealing with API smell. It's just too complicated. It shouldn't be that complicated. In Kotlin, it's considerably simpler. You simply have a list of integers and then sum. But why is it simpler, right? Well, first of all, Kotlin has all these nice collection methods, and we'll see more of them right away at the collection, so you don't have to do this indirection to stream and back. And second, Kotlin only knows object types, no primitives. Of course, Kotlin has primitives in the bytecode, but Kotlin considers primitives to be something of a compiler concern and does not want to burden you as a developer with primitives. And that's why actually these two indirections can go away, making it more concise and more user-friendly. So you won't find a Baldung for a sum in Kotlin. Well, let's look at probably more sophisticated higher-order functions like a group by. So what we try to do here is we have a list of users and we want to group by them based whether their email address is verified or not. And also here, you're probably going to need the Baldung, because what's kind of hard with streams is that certain operations you have to do in collect, others you just can do on the stream, but what you have to do when? Maybe when you program everyday Java, that might be fine, but if you don't, it's kind of hard to figure out. And in Kotlin it would just be straightforward. You have your collection, then you have your higher-order function, job done. What we try to do here is do a swap. So we have a map, and then we like to swap the key and the value, which is again a mouthful of code. In Kotlin, what we see is that all the higher-order functions are available on all kind of collections, so not only on stream. So no matter whether you have a list, a map, a set, a range, even an array in Kotlin is a generic type. And of course in the bytecode it's array for efficiency. But Kotlin doesn't have this distinction between collections and array, different syntax and so on. It's just made easy for you as a developer. It's a collection type. And even a string is considered a collection because it's a collection of characters. So all these types have the same API, which is really great to solve your problems. Moreover, you also can easily convert from one type to another. So all these parts can go away. Second, what you also have in Kotlin is called destructuring. So this meaning taking an object apart. When you create an object, you create it with a constructor. When you take it apart to its individual elements, then you would use the destructor. And the destructor is really great to give your code more semantic. So instead of having to deal here with a key and a value, like here in the Java example, we now name things. It's a name and an age, and we're gonna swap those. So your code is getting more expressive. And I could go on and on with collection examples that are more horrific than the ones here, just to give an idea about conciseness in Kotlin and collections. Whenever you try to get an overview in a domain, then in Java this can be a bit tedious because all the public files need to be in their separate file. All the public classes need to be in a separate file. Kotlin has this simple feature where you can put multiple public classes in a single file. In Kotlin, classes by default are public, so there's no public required. So here we really have 3 public classes in one file. And that's great because at one glance, we get a nice overview of all the classes, of how our domain looks like, and how these objects are related with one another. So nice feature. So what do you gain with conciseness? What is the benefit of having a concise language? To put it in short, this is more or less the benefits. You get about 30 to 40% more code clarity. Of course, there's a lot of reduction involved, but reduction itself is not a goal by itself, right? You want to have expressive code that is easy to read, that doesn't contain redundant information, that is just kind of crisp and depicts the crucial information. And that's quite significant, right? This means 30% less to write, to read, to maintain, to bug fix, and so on. Okay, you might also have heard that Kotlin is a safe language. Well, first of all, what does that mean, safe language? And again, what is the benefit of having a safe language? We all know that nullability is a big issue, not only in Java. Actually, all the languages, they have to suffer from nullability. The developer who invented nullability said it was the worst error that happened in the whole industry, the billion-dollar error or multi-billion-dollar error. And Java, of course, had some iterations to kind of fix that. By now, you have annotations and optional types. And that gives you a certain level of safety, but it's not really that safe, because I still could write this particular piece of code that would compile, and runtime I would get null, because I still can assign null to an optional. And I've seen this in code, so people do that because you can. In Kotlin, they of course realized this nullability is a fundamental issue, so they also solved it on a fundamental level. They put it in the type system. So in Kotlin you have the normal types like string, boolean, and so on, and then with the question mark you get a nullable type, which is actually a superclass of a normal type. And as such, you only can assign the null keyword, so to say, that's what it is in Kotlin, to nullable types. Other ones wouldn't accept null. So instantiating a user like that wouldn't compile in Kotlin. And that's what we always want, right? We want our compiler to fail, not our program at runtime in production. What's more is that when you have to deal with optional, it's not that convenient, especially when you have nested optionals, right? Because then you quite quickly run into this flat map hell. Kotlin has this nice question mark syntax, so when I have a graph of nullable types, I can easily traverse the whole graph, and whenever one element would be null, well, I would jump right away to the outcome part, which comes after the ternary operator here, Elvis operator. And of course, nullability is very well incorporated in all APIs of Kotlin. So for instance here, first or null, because when you have an empty list, the first element might be null. Higher order functions that are not safe, like a max. When you have an empty list, you won't get a max. Also here, also there, max or null. You can do a safe cast. So whenever the program could cast your value, it would be a cast. Otherwise, you would get back null. So actually, all these operations have kind of safe possibility attached to it. And it's no wonder that, even though I find it surprising when you work for a long time with Kotlin, it's the most loved feature in Kotlin. And it's probably not because Kotlin offers it, it's more because it hurts so much when you don't have it, right? But nullability is not the only safety feature in Kotlin. There are quite a few more. The second are primary constructors. So what does that mean? In Java, when I have a class with mutable state, I can very easily create a no-argument constructor, which is dangerous, right? Because now I can create my user, and when I then call get email, which would be null, well, I get a null pointer exception at runtime. In Kotlin, because you have this primary constructor concept, it implies that all code that must be executed to instantiate object must go via the primary constructor. So when I have a secondary or a third constructor, in the end, they always have to call the primary constructor. And the primary constructor ensures that my object is instantiated correctly. So nothing can accidentally go wrong. So this is what I have to do, something else wouldn't work. Smart cast is also an interesting feature in Kotlin that is related to safety. Java also has, at least all the examples show you of Java are really latest, greatest versions, 21. You also have this smart cast here, so you don't have to cast user again. But again, this is actually only limited to normal types, not nullability. Kotlin also have smart cast, so when you have any is user, then Kotlin knows that from here on, any is a user. And when I then also check for nullability, it would also smart cast my nullable type to its non-nullable type, which in this particular case would be a URL. Which again is just a bit safer, so if I forget to check for is present here, I could get a runtime exception, whereas this wouldn't even compile if I would forget to check for it. So it's convenience and safety in once. So what do the safety features deliver us? Quite a lot. They deliver us about 30% less bugs. And this means there's more time to develop features, right? Not irritating time to debug, to figure out stuff, or even explain your boss why this thing crashed in production. So you just have more time to do fun stuff. That's basically it for us developers. And your boss is happy too. And of course, this is available for all GVM features. Like for instance, SmartCast is only on 21. In Kotlin, no matter which feature, which GVM you use, all of the features are available. Okay, what we also see is that Kotlin favors immutability more than Java. Even so, Java also has made some efforts to make immutability more accessible. In Kotlin, it's definitely from the ground on a very strong concept. What does that mean? Well, in Java you might have heard of these record types. The counterpart in Kotlin would be a data class. And you might be tempted to think these are the same things, but they're not. They have some commonalities, but there are some crucial differences. So one difference, for instance, is that in Kotlin you can have mutable state in a data class. I don't say this is a particularly good idea, but you might have this corner case where this might be very valuable. So then it would make sense to do it. So what they have in common basically is a nice representation of the toString method, right? You just get all the properties printed out. They would do equality by value rather than reference. But here actually the big difference lies. Whenever you try to create a copy of a record, what you have to do is copy all the state yourself, which is first of all very tedious, and second, also error prone. So if I have two string arguments here and I swap them, well, I've introduced another error. Kotlin kind of also fix this in a very neat way. Whenever you have a data class, this copy method would be compiled in, and then together with the named argument feature, I would just adjust the element I would like to fix or like to adjust, and then I would get back an immutable copy. So working with data classes is really a wonderful way to work with an immutable domain in a very effective way. But there is actually more oddities here. So records are not compatible with Jakarta persistence, at least not for entities. You can use them as query replies, that's fine, but for entities they're not suitable. Where data classes are. So kind of really weird thing that a Java native framework kind of doesn't support the latest constructs. Okay, then let's also look at immutability support of collections. So what do you think happens when we execute this piece of code on the left? Any ideas? Exactly. You get an unsupported operation exception, which is really not safe, right? So there are immutable collections in Java. This gives you back an immutable collection, but it doesn't really tell you, from user perspective, that it's an immutable collection. You will find out when it's too late. In Kotlin, by default, collections are immutable. So you have list of, and then you would get an immutable collection. If you would like to make a mutable collection, then you would have to use the mutable keyword before, because Kotlin actually wants to really nudge into the direction of immutable constructs. So that's why you have to type mutable to kind of make you think twice when you want to do that. And when you add something to an immutable collection, well, this would work in Kotlin because you would simply get back a new collection where this element has been added. And what's really surprising is if you copy-paste this snippet in Kotlin, it works. Because apparently, well, this plus would be called on the water, so you wouldn't get the exception here. So running Java code in Kotlin is safer than running in Java. Weird world. Okay. Another interesting feature, functional. Kotlin is more functional than Java. What does that mean? We know that since Java.8 we have lambdas in the language. And the way they implemented this is by means of these functional interfaces, of which you have quite a few. And most of them you have because you still have to make this conversion from box type to unbox types. Also here, this primitive and object duality leads to certain problems. But there is a fundamental problem or issue with this approach. Functional interfaces actually hide you the relevant information. They introduce an indirection. What's really relevant for you as a user is this single method in the functional interface, which tells you what goes in the function and what goes out. By just looking at this signature here, what goes in the function, what goes out. You have to understand the concept of a consumer to know how this works. So it's not that a string goes in and the buffered image goes out. No, it's that string goes in, buffered image goes in, and unit goes out. Kotlin considers functions as first-class citizens, so in that sense, they made it very simple for you to define functions that are also very readable. So here we just read what's written here. A string goes in, a buffered image goes in, and unit goes out. As such, first of all, you won't use all this indirection. And second, because this concept is easier to use in Kotlin, you're also more prone to use it because they're really great and powerful constructs you can accomplish with functional programming. Okay, then last part, and then we're going to move to Spring Boot, flexibility. Kotlin is considered more flexible than Java. So what does that mean? And also here, okay, why is it a good thing to be flexible? Whenever you try to add functionality to a Java class, the only way to accomplish that is by writing these static wrappers. So whenever you have a certain API that you don't find in the library you get, then you go look for some common library that wraps stuff so you have this particular piece of functionality. That's the way it works. Kotlin has this very simple concept of extensions. So if you have heard of extensions, not many. So some of you still learn something new today. That's cool. What? Terrible concept. Yeah, okay. We will see if it's so terrible. Let's first look at the facts and then judge. So this concept means that you are able to extend existing classes with new methods, right? What you actually do here, you do here in a very simple way, in the sense that you define the type you want to extend, then you find the method name, and from there on, when you bring this particular method in scope, you have this method available. So, I don't think it's a terrible concept. It is an awesome concept. Why? At least that's justification. First of all, it leads to more fluent code. That's easier to read and write than always this wrapping. But what's actually quite important is it will show up in code completion. These wrapper functions, even though they are there, they won't show up in code completion. Maybe with Copilot they might suggest you stuff, but that depends. Here you just hit code completion, you get it. And the third one is also very, very interesting. Because you need to have these extension methods in scope, you now can add certain features of your class only in a particular layer of application, which allows you to, for instance, certain conversions like to DTO and to entity, you don't want to have in all the layers. You probably only want to have this in the controller layer. But in the other layers, you kind of don't pollute your class with these kind of functionality. Without extensions, Kotlin wouldn't be such a user-friendly language, while at the same time being perfectly interoperable with Java. Why? Well, for instance, here we have some cool methods on string, and these are all extensions. You as a user don't even know that. You just think it's API, but actually it's just the Java stuff, but then pimped with extensions. Which, well, how do you do your reverse in Java? You need a baldwin for that. I mean, when you see it, it's kind of evident that you need here we use string, but on string itself, again, it's a hard thing. API smell, so to say. There are also cool extensions on libraries that are, again, hard to use in Java with a lot of wrapping, like, for instance, the stream API to doing I/O. So you have a copy to output stream and so on, for which, well, guess what? There is also balding available. What you also have in Kotlin are many third-party extensions, like the ones we see here, GDBC template or object mapper, which, that's a nice use case, allow you to omit passing a class or type reference when you do some serialization. And what's also cool is, for instance, for testing. So what we see here is a method on everything. You can also have extension on generic types that even does miss this dot and parents. So here we actually don't really talk about extension, even though it is an extension, but here we talk more about a DSL. That's another very powerful construct in Kotlin with only a few language features, basically 4 features. You're able to write very decent DSLs. So the first one would be the operator. That means I can write operator plus, and then I could call this method with the plus sign. So what you saw with the collections, I showed some slides before, that you add an element to a collection is basically calling plus on the border, but by using operator plus, you can use the plus sign. Then we have infix notation. That's actually a notation where you can omit the parentheses and the dot. Combine them with extensions and functions. This is actually all that is needed to create such DSLs, which are very convenient to read and write, and also would give you very expressive information when a certain test would fail. And of course, there are many more DSLs available, also in Spring Boot, as we'll see later on. So these are kind of the concepts we compare from Kotlin to Java. That, I think, is a good question, right? So Java is definitely not standing still. They're innovating too, adding 2 features. And why not just wait until I got all the features that are already now in Kotlin? That might be a strategy. I think it's not, you won't get there. So this is the stance I take. That's true. Java is really doing a great job in its evolution. So I would say all the modern features Java adds, they're really great. They're kind of moving the right direction. They are immutability, you have pattern matching, and so on, destructuring, mostly stolen from other languages, which I think is a good thing, because then at least you incorporate something that is proven instead of just inventing the wheel yourself. What's really missing is flexibility features like extensions, DSLs, which also there is no project yet that would incorporate them. But I think the fundamental part that is really lacking in Java is more on the foundation. It's things like conciseness. So the class declarations, collection usage, primitives, functional programming, simple things like default argument, named arguments. Actually, these very simple core features make Kotlin work so nicely. And they're just lacking in Java. Same for safety. Lack of safety is a very crucial thing. So these 2 foundational features are lacking, and they won't be fixed anytime soon. What's more is that the more feature integrate in a language, you will also introduce ambiguity. Now you have a switch statement that has a side effect, the old switch statement, but you also can use it as a new switch statement. You have records and classes, when to use what. And the more features you add, the more kind of complexity to introduce, what do we choose now? And that's kind of nice seeing Kotlin. Kotlin 2 was released last week, but there are actually almost no new features. It's mostly in the compiler space where they did a new additions. But the language itself stands very strong. There are not really big additions planned or added because it's good enough for what we have to do now. Maybe next year when we program differently, okay, we need another tool. But for what we do now, it just works. And that also might be interesting depending what you do. I think we are mostly backend developers, so that's not so relevant for us, but Kotlin is also by now a real multi-platform language that allows you to compile to all targets out there. Not only Android and iOS, but also Linux, Windows, so you really can build rich desktop applications with multi-platform. And they're heavily investing in it. Google is supporting it. So this is a really interesting movement you have with Kotlin 2. So if you would kind of depict at a glance what is the difference between Java and Kotlin, if your challenge is to mow a grass field, well, you get the job done with Java. Definitely. No doubt about that. You just have to push a bit. With Kotlin, you get it done faster and with more fun. That's more or less it. We see Chadef again asking a question. Yeah, that's true. I mean, there are not as many Kotlin developers as there are Java developers. That's an argument we hear very often. However, first of all, why are you here on a conference? Because you want to learn something, right? We like to learn stuff as humans. So, and we even can do that. Humans can learn new things. It's not impossible. So that's for one. And second, it's not that hard to learn Kotlin. Why? Because when you come from Java, you will use the exact same APIs, the exact same framework, just a different language. It's really like changing from pushing this grass mower to a John Deere where you know how to steer and maybe start the engine and so on. And within no time, you're productive. So the learning curve isn't that great. Well, which brings us to Spring Boot, because you can use the same framework. It's of course awesome when you have a language that has great features, but if your framework doesn't support it, you're still screwed, right? If you cannot use them, it doesn't make sense. This brings us to this part. 7 years ago, Spring announced official support for Kotlin. Then we had this nice remark of someone, I don't know him. He said, yeah, Scala was a failure in Spring Boot. Only time will tell if Kotlin will prosper or fade away. Now, 7 years have passed. Let's see where we are. And we do this by means of a very simple application, fully working. So this is a fully working application that fits on one slide, which also depicts actually most of the features Spring Boot Web offers you with Kotlin. And if you run it, it might even lighten your day a little bit. So let's look at individual parts and see what you get when you use Spring Boot combined with Kotlin. The first one is kind of an odd thing, I personally think, a design choice in Kotlin which says that if you use inheritance, you have to design for it. Inheritance should not be kind of an open door you always can use because you might break internals. So you have this very puristic view in Kotlin that says, by default, classes are final. If you want to design them for inheritance, you have to open them. Well, even though that sounds like a nice idea, it doesn't really work well the way Spring Boot treats your classes. Because, as you might know, certain classes in Spring Boot, there are proxy beans generated by means of cglib, and then do this by subclassing the existing class. So in order to achieve that, you would have to mark all those classes with the open keyword because they'll be subclassed, which I agree is annoying, right? I mean, it's not a big deal, but it's still a bit annoying. The good news is there is a nice plugin to work around this limitation for Maven and Gradle, of course. It's the all open plugin, which actually makes all your classes open by default in a syntactic way. And syntactic means that it's only actually in the bytecode, but not you as a user can extend from these classes. So it's really kind of a best of both worlds approach. It's open, but not for you as a programmer. So they nicely fixed this. So no more open keywords there. When it comes to dependency injection, it's the same like in Java. If you only have one constructor, which we always have, right? You have the default constructor, then you can omit auto-wire. When you use the add value notation, the only thing you have to use is a backslash for the dollar, because Kotlin has string interpolation, and a dollar would be used to reference a variable in it. What's really great in Spring Boot is that nullability is fully incorporated. So what I can do here is say category, string, question mark, so I get a nullable string. So no kind of back and forth between optional. I really can stay with the Kotlin specific concept of nullability. We also get these nice extensions. So here say get for entity, then provide the type rather than providing the class. Also just a kind of really Kotlin specific way how you use this API. And when you have the checks and Kotlin module in the class part, well, then you also get data class serialization out of the box without even realizing it. I used this for quite some time till someone told me, hey, this is not automatic. This depends on the version you have on the class part, and then Spring adds a module to your object mapper, and then it just works. So you won't really recognize it. Very good support for that. And then in the end, you have your main method. What we see here now is basically the exact same thing like before, but then written in a very different style. Spring introduced some years ago a way to define interfaces or endpoints in a functional way. They're called functional endpoints. Who is using these? No one. Me neither. I think this, because this is actually what you get. You have to have distinction of server request in, server response out. And when I see this, I kind of see the servlet area kind of haunting me. Where I also had a request in, a response out, without the nice kind of visualization which I automatically would have if I don't have to deal something with server request and response. But well, some people apparently liked it. This is also getting Java, by the way. This is not a Kotlin specific feature. What's Kotlin specific is kind of a nice feature, and if you like it, it's really up to you. You can create all your beans in a declarative way rather than using the @bean annotations or @component. So you would create a bean REST template. Here you could use ref, which kind of, oh yeah, there's a ref bean, so I'm going to search one and then I'm going to inject it there. And then here we would have this route to DSL. It's a great DSL, which now only has one get method, but could have all your routes could be nicely described in a declarative way. And then you would point to this handler method. Then what you have to do is add this beans configuration to add initialize, and then you have the exact same application as we've seen before. There is some efficiencies going on here because, well, no CGlib proxies would be to have generated, right? And also class-path scanning would be a bit faster, so you have a bit of performance win. But well, I said it's cool, but I have not used it and also not plan to use it. But up to you. Maybe nice to play around with it. What's remarkable in that sense is that with Kotlin you get more features than what you get with Java. That's kind of a remarkable thing. Okay. Of course, when we create applications, we often also have to deal with persistency. So how well is Kotlin compliant with the generic persistence approach out there? So this is what we do here, right? Our endpoint has a get and a kind of insert endpoint, and that's what you can do with it, and the repository. So first of all, if we use GPA, so who's using GPA? Okay, about half. I would have expected it to be more, but okay, fine. It's the de facto standard. If you like it, there are definitely other solutions, but well, standards are standards. What's kind of interesting with Jakarta persistence entities is that they require you to have a no argument constructor. And our Kotlin made a lot of effort to avoid those no argument constructors because it's not safe, right? And actually now I have a framework that wants you to use an unsafe construct. So how does Kotlin deal with that? Also here, we have a plugin that solves this problem, which is a no-arg plugin. So this plugin will generate an argument constructor, again in a syntactic way. So it's only in the bytecode. You as a user in your code base cannot just create an instance with a no-argument constructor. So problem solved. When it comes to repository, you have the exact same feature like in Java. And on top of that, you also can have now return types with nullable types. So no optional, which is great. And the same is true for these find by ID methods, which in Java would return an optional. In Kotlin, you have then the find ID or null, which would give you nullable type. So nullability on all levels in Spring Boot is incorporated. I've not ever had an API where I had to kind of do a conversion from optional to nullable, which is, by the way, very simple, but still, it wouldn't feel that great. Using data classes as entities is a bit controversial because the data class generates a toString implementation. And if you use some bidirectional bindings with a construct argument, you might run in Stack Overflow exceptions. So it's not 100% carefree. I've written many applications with data classes, as entities. When you know the limitation, it's fine, but maybe you think, that's too dangerous for me or for my environment. Well, if you step away from data classes, you probably couldn't use copy, right? Because copy is only available in data classes. So would you then miss this kind of convenient feature? Well, the good news is not really. So if you use mutable entities, then you simply would mark your attributes as var instead of val, right? Val is immutable, var is mutable. And then you still could use one of Kotlin's scope methods, which is apply. Apply basically gives in the block the reference to itself, and then you simply can call all the methods, which gives you the same kind of flexibility like with copy. So no really feature degradation there. When it comes to testing, also here you have a nice experience in the sense you can inject all the dependencies. You have to use test construct for that, but you simply can inject them. Then you get really immutable objects. Immutability is great, so they cannot be adjusted, changed, or break something. Even annotate your mock k-bean, which then will be replaced with a mock, and so on. So that really works great. What's also nice in Kotlin is that with the backticks, you can actually define method names that contains any Unicode character. So also a space. And even so, I don't advise you to use methods names like that. For testing, it's great, because it makes your test description very, very readable, instead of the camel case approach. And of course, you have a nice mocking library, which, as you see, the way you create is more DSL-ish. It's quite natural how you create these structs. What you also will see is, and that's why I really think extensions are a good thing once you embrace them, this kind of code, for instance, serializing a payload and then checking for it is something you will probably do in many tests, right? Well, in Java, the only way we have to deal with that is or you copy-paste it or you would use a wrapper. But the wrapper kind of doesn't really work nicely with these DSLs. Or maybe you miss a check method on the DSL. And also here with a bit of code, like what you see here, m_body_as, I can simply extend my DSL, and make this particular piece of code considerably easier to use, also more uniform, my tests are more uniform, more crisp, and so on and so on. So quite some benefits there by having extensions. This also goes kind of natural. You will automatically build up some APIs that perfectly suit the needs, what you have to accomplish in your test. So far, so good. I see that Jadev is using Spring Boot Webflux. Who of you is using Spring Boot Webflux? Okay, that's not much. And who of them who is using it likes it? One person, 2, 3, wow. But it's definitely less than the hands that went up initially. Okay, so for the ones who have not yet used Spring Webflux, be prepared. But we probably have to first answer the question, why should you use Webflux in the first place? We have an example here with 2 methods we're calling, and then we save user, and these are all blocking calls. That's what we assume, right? And that's easy, because, well, this is just kind of so straightforward. You have a method that gives you a type and do something with the type. So from an easiness point of view, it's great. But, if you look at this code, we see that it's resource inefficient. What does that mean? Well, because you're blocking threads, we might eventually run out of threads, because if you get a lot of load and all threads are waiting, there are no threads available to take on new requests. So we can get unresponsive. And what's more is, we cannot really leverage parallelism here, right? Random avatar verify email, we actually could execute simultaneously. But because we don't have a kind of a way to accomplish that in an easy way, we just do it sequential, even though we could do it in parallel. So these are kind of disadvantages. Well, reactive programming is already there for quite some time, and they actually have an answer for the limitations I just showed you. The code would then look like this, and they really solve the problems we've seen. So it's resource efficient. Now threads won't block anymore because all the APIs are async. We have now parallelism support. Who sees the parallelism here? Come on, it's 6 lines of code. Zip, yes, excellent. So zip is parallelism support. Kind of straightforward, right? And what you also get is that this particular application is responsive. What does that mean? It means that because no thread is never blocked, I always can react in my application. Okay, so this still sounds kind of good, but the price you pay to get these issues fixed is quite high. So let's take a look. First of all, now all of a sudden, my domain classes are wrapped within these monos. Right? So my code is not about what I'm carrying, Boolean URL user, it's about mono of something. So wrappers everywhere. Second, that's a kind of a limitation. I only can use non-blocking libraries. And I get these complex operators everywhere. It's great that you know now that zip does some parallelism, but it's not very natural to assume that, right? Then you have this flat mapping going on. You need to know a bit about monads. Before you know it, you get down a rabbit hole you probably don't want to get. And what's even more is we cannot simply use standard programming constructs anymore. Right? What we have here is that we even have to wrap kind of exceptions in a monotype. You can throw an exception, it would compile, but it would give you very weird behavior. And what's probably the worst of all is that with this piece of code, or with this code when you write Webflux code, is that your business intent is really getting lost. And this is what's very important for our maintainability of your project. This is a simple example, right? Business use cases are way more complex than this, but you can kind of extrapolate how this will look like with a serious business problem you try to solve in this approach. It's also very hard to learn, and it's very easy to shoot yourself in the foot. There's also there quite some, well, disadvantages. So we can say that from a resource perspective, reactive programming gets the job really done. I mean, when it runs in production, it's a super duper system, but accidental complexity is tremendously high. Is there a remedy? Well, that's actually good news, which is coroutines incorporated with this particular stack. So what are coroutines doing? Well, they allow you to harvest the best of both worlds. They allow you to express your logic sequentially while executing the underlying logic asynchronously. And more or less the only thing you have to do is mark these methods suspend. So let's give you a look before we go into too much detail. So this would be a web client method in Spring Boot that is reactive. In Spring Boot, we have first-class support for coroutines. So what you would do is mark this method suspend, then have another extension method that converts this mono into suspend call. And now actually my mono is gone, right? I have my URL back, yay. Same is true for our repositories. If you do reactive stuff, this would be the repository you have to use, reactive CRUD repository. Spring Boot offers a coroutine CRUD repository that allows you, first of all, to create these suspend methods and then return, with the same kind of query syntax, return a user rather than a mono, which has two advantages. So first of all, the mono, which is just in our way, is gone. And second, I also have now nullability introduced. Whereas here in the mono, I actually don't know whether this thing is null or not. I have to check for it. It's not in my API, in my type system. So this is much less safer code. This is safer and easier to use. So really the best of both worlds. So let's see this in action. The only thing you have to do is add these dependencies to a class path, and of course Kotlin. Now let's convert this piece of code to give an idea how simple it is to use coroutines. So what I have here already are these dependencies injected. This would be the example we've just seen in the slides. So the first thing we're going to do is fetch this avatar. Random avatar, so that's for one. Now it complains that, hey, it's a suspend method, so you cannot call a suspend method from a normal method, so you have to make it suspend. And this keyword that this all works in Spring Boot has taken them quite some effort to accomplish that. But it just works in Spring Boot. It's awesome. So you start with suspend. From there on, you can use suspend methods all the way. So then we have email verified. This would be the enrollment service we call here with the user's email address. Then, that's nice with this way of program, we just can do if else, right? So if is not a valid email, then I would throw an exception. So I just can now throw exceptions again. And else, I simply would store this user in my repository. But of course, I would like to adjust my avatar URL. For this, I need this builder here. Well, in Kotlin, you have nice data class support, so I would simply say avatar URL is avatar.url. Kotlin if else is an expression, so it returns a value. So that's it. And here we still need to return a DTO. Nice extension method pops up in my code completion to DTO. And I think this is maintainable code. For now, it doesn't perform as well as the code below, because in the code below we do things in parallel. So how can I introduce parallelism in my use case? Again, easy peasy, use async await. For this we need a coroutine scope, and then we can use async await. So here you've seen we would have to await the result. All non-blocking, of course. So Kotlin would figure out by itself that it needs to wait in a suspension way. So no blocking, fully asynchronous support for that. So the only thing you have to know here is actually that you have async await, and for the rest you just would write your code as you did. Which of course, especially when these use cases getting longer and longer, is so much simpler than this particular approach. Because of a lack of time, also would have loved to show you a bit how you can simplify tests. With reactive tests, you have these step verifiers. You cannot debug. Again, a lot of headache to do something simple like a repository test, which in with Coroutines is just writing the tests in a way you're used to. Okay, you might say, well, that's all nice and dandy, but now with virtual threads. So why you need all this reactive stuff, right? Yeah, no. Okay, so the short answer is no. It will solve one particular problem. The long answer is, I did some webinars about some months ago. You can just watch them on JetBrains, where I go in much detail, really to the bottom of it. Also what Loom will offer with structured concurrency, so all the possibilities you will get. You get quite a good overview of what you can, what are limitations, and so on. So because we have only an hour here, or less than an hour, I can't go into detail that. But just give you an overview. For now, we can say that first of all, virtual threads is not something that is only for Java, right? It's on the GVM. So all the languages can provide virtual threads. And second, virtual threads would rather complement coroutines rather than kind of compete with them. Let me show you. So how do you enable virtual threads? You might have seen it by now. You would need this Spring Boot versions, GDK 21, and then you just enable virtual threads, and then your virtual threads. But if you have a truly active application, you won't get any benefit. Why is that? Well, if you have an application that is truly built on asynchronous library, like web client, for database access RTDBC client rather than GDBC, your application is as efficient as it can get. Virtual thread only would actually add a layer of abstraction in it, which just costs you more performance. What virtual thread do not support, and it's often forgotten, is they do not support parallelism. There is no construct where you can execute things in parallel. For this, you need structured concurrency. And we just saw this in action with async await. There is no async await in virtual thread. It's just a lightweight thread. Basically, a coroutine doesn't block. It's like a suspend call. That's what a virtual thread offers us. So where would virtual thread then come in? What kind of problem could it solve? Well, what virtual thread do very well is kind of make blocking calls non-blocking. That's kind of the magic they introduce. So if I have some API that is blocking, meaning I use Java I/O rather than Java new I/O, right? Neo, REST template, so to say. So if I have a call that would use a REST template here, then the way you did this prior to virtual threads in reactive applications is use a separate thread pool, that's here denoted with dispatch I/O, that would then call these blocking calls with a thread that we can spare, so that the main thread, the event loop thread, wouldn't be kind of occupied. This is how you solved it. The potential problem, it's really a potential problem. It's almost actually never had this, even so with applications running for years in production, is that if these blocking calls take very long, you get a lot of traffic, you still might run out of threads in this pool. And then new requests would have a problem. And here actually, virtual thread could do a great job. So what you could do is, this is the code you have to do. You would say virtual thread task execute as coroutine dispatcher. This is the conversion to it, and then you feed it in here, and then all these blocking calls wouldn't really block. That's the advantage virtual thread could give you to combine with coroutines. Okay, so I think it's time to round up. Pain or gain? Spring with Java gets you definitely harvesting a lot, but the marriage with Kotlin between Spring Boot is really, really a happy one. It lets you reach higher in the tree. You get more fruits, right? You get all the good stuff of Kotlin. We've discussed it in the first part. It really feels Kotlin native when you program in Spring Boot. They really put so much effort in making it a first-class experience for Kotlin developers. So thanks a lot to Spring Boot to make this possible. That's why I have all these extensions. You have some additional DSLs. Maybe you like them or you don't like them, but the game changer really is if you do reactive programming, Coroutines is important. That makes life so much simpler. That can really be a game changer for a company. And I train companies that made the switch from Webflux to these Coroutines, and it's kind of a wow experience. So, any pain? Well, if I had given this talk about 1 to 2 years ago, there were still some parts on the construction. Especially the Coroutines part wasn't that implemented that well. Certain annotations didn't work, like security annotations. Transaction worked out of the box, but there were some issues. But by now, they're all resolved. It just really works perfectly. So as such, well, the only pain is maybe to learn Kotlin, but apparently you already did that, so that's wonderful. So it's actually then just a matter of climbing this rainbow further and enjoy all the good stuff that is up there. Thank you.
Thank you. Does it work? Yeah. I would like to ask whether if it's good to switch coroutine scopes for like blocking calls, like network calls or database calls, like always do it or not, like for the dispatcher IO. Isn't it expensive somewhere?
No, there's no performance penalty involved with it. So, and you have to, because you don't want to block this asynchronous thread. So, and in that sense, there's also no overhead involved with it. And as said, I would then advise you to use virtual threads to do that. That gives really the perfect combination. Dispatcher has this limitation that it could potentially get exhausted, but with the virtual thread dispatcher, you get the best of both worlds.
Okay, thank you.
Yeah. Yes.
Thanks. Do we need to use Webflux to use the coroutines, the suspend, or we can use MVC or?
No. So that's also in my talk, by the way. What you often see people doing is they use Spring MVC, and they want to do stuff do in parallel with Kotlin, so they use run blocking, right? Because run blocking gives you a kind of scope, and then you do your stuff. But you'll see this in the talk. If you do that, you won't get any parallelism. It's kind of a very counterintuitive thing. So you really have to understand how these coroutine scopes and contexts work. So it is not advisable to do that unless you have some corner cases. So if, for instance, you don't need context in the calls you make, so you say you want to make 2 parallel calls on a REST API, and you don't need context from your controller like a transaction or a security context. So you're kind of a context-free, also no MDC context, so you don't care about context. Then you might use run blocking with a separate dispatcher or virtual thread dispatcher. That would work, yeah, but only then.
Thanks.
Yes.
Hi, thank you for the talk. I have 2 quick questions. First, you told that Kotlin provides about 30% decrease in bugs producing, and are there actually any studies that proves this number?
I said what I included is some. It's my experience, by the way. I didn't in that sense have kind of gathered statistics myself, but I started with a Java project coming from Scala at that time, and all of a sudden I had null pointers. I thought, whoa, all of a sudden I'm a bad programmer. Till I realized, hey, this is not me. This is the language. So you quite quickly kind of also will experience this drop in these kind of weird errors which you simply don't get with Kotlin. And this actually is what Google published. They analyzed that. And these statistics are taken from there. So this is the one here, and also about these less bugs is from there. Oh. It's on Android, but it doesn't really matter if it's Android because it's just a Java code base. So in the backend, it's the same. And said it really covers also my my experience.
Oh, okay, thanks. I just had an issue to prove this. I came across a lot of such number, but I couldn't prove when I was convincing my team to use Kotlin.
Okay. Yeah.
And the second question is, what do you think about the problem with extension functions and shadowing of them when you add the same name function in your class?
Yeah.
Or
Yeah.
the class you're extending, actually.
Yeah, I said, I mean, extension functions, it's a powerful feature, and with great power comes a certain degree of responsibility. Of course, you can mess things up. That's always with great power. The question is, does the power introduce more headache than it yields a reward? And you could, of course, use shadowed methods. Normally, ID would help, right? You would see an ID that you've created something shadowed.
No, I'm talking about a problem when you now you extend a class from a library, and then some time passes, and this
method would be added later on.
Yes,
yeah,
yes,
yeah,
and
okay.
you cannot predict
Yeah.
this, and maybe it is for me it's one of the major disadvantages of extension functions. I still use them, but I'm worried about this and wanted to know what do you think about this problem.
So I said, for me, it sounds really like a corner case. I've never had it. It's also the question whether you will extend many third-party library methods, because normally all the libraries already have some extensions for Kotlin, and they're well maintained. And when you use these, you also will be very much likely to run into this particular problem. We use, at least in my domains, extensions on our own domains to do nice conversions. That's where and then you won't have this problem that quickly. So maybe if you run into it, that the library doesn't support it, probably, issue some requests that they fix it in their Kotlin extension pack. Yeah.
Thank you.
Cool. Okay, excellent. Thanks.